This is a tolerancing project we do for ME110 manufacturing processes at San Jose State University. Our members include Kiara, MZ, Justine, and Anthony. Here is the product that we choose for tolerancing project. The project is coming from Kiara's senior project. They are currently developing a dynamometer for electric motors that will be used in Spartan Superway vehicles. To assess the hub motors, we place them between two rollers. These rollers utilize the bearing and bearing housing that will be demonstrated for this project. Here are the reasons for choosing. Since the power of motor can reach to 1 to 5 horsepower, the diameter of the pipe needs to be large enough for transferring the force to rollers. It also decides the size of the bearing, and the bearing needs a bearing housing to fix on the rack, so the pipe can rotate horizontally when the motor is running.
The ball bearing consists of two components, the actual metal balls and the rings or races. For our purposes, we are only interested in the races, since this is the part that will mate with the bearing mount. The races go through a variety of different processes during their creation. The first step is to lathe steel into a shape similar to the basic shape of the bearing, but slightly bigger since heat treatment will be necessary to harden and toughen the steel, and the heat treatment will cause the material to warp. The final step is grinding the races down to the desired size and finish. Since this includes the finish of the bearing, this is the step that we are most interested in for deciding the GD&T tolerancing. The typical tolerances for grinding are 13 micrometers to 1.3 micrometers for the diameter and 2.5 micrometers and 0.25 micrometers for the roundness. The video in the bottom corner is an example of this grinding process.
The purpose of the ball bearing is to reduce rotational friction and support radial and axial loads. It achieves this by using at least two races that contain the balls and transmits the load through the balls. For the ball bearing, we chose a tolerance of 0.01 millimeters for the outer diameter of the race, which is well within the capabilities of the grinding process. The ball bearing has a specified diameter of 34.93 millimeters, which was press-fitted into the bearing clamp and also snugly fit a 5/8 inch rod. For the bearing mount, we chose a tolerance of 0.1 millimeters. This is because the part was manufactured using 3D printing. The typical tolerance seen for 3D prints is 0.127 millimeters for tight fits. So this is within the capabilities of the manufacturing process. The mount is given the same position as the bearing to ensure the two components can be mated. Due to the fact that this part is 3D printed, we don't have to worry about any shrinkage unless we print with nylon 12 or other materials that lead to shrinkage.
GD&T stands for geometric dimensioning and tolerancing, and it is important in communicating the intent of the design rather than the actual geometry of the part. In other words, the purpose of using GD&T is to ensure the part is functional and reduces costs for manufacturers by allowing less important design features to have larger tolerances. Using GD&T establishes a distinct categories of imperfections, which include size, form, orientation, and location, and also standardizes a mean in which to communicate design intent in terms of these imperfections. Thus, GD&T is a better alternative to conventional tolerancing because it allows manufacturers to meet the functional requirements of a part without the unnecessarily tight conditions.